Hello, and welcome to this presentation on the walkthrough to the answers of the ever-changing Earth exam style questions. So, starting with the first set of questions then, these were to do with the atmosphere and gases, and the very first question on this sheet was to do with some article information based on global warming, whereby some data was also given regarding this. So, the first part of this question then asks for you to draw a trend line on the graph associated with figure 1, and this was showing you how the mean global temperature of the Earth has changed over the shown time period. Now, there are two ways which you may have gone about this. One was that you could have drawn a line of best fit to the bar graph as shown here, and this will describe a linear change of global temperature as the time went on. Or you may have drawn a curved line of best fit, so to say, which will instead show you that the temperature increase over time was sort of linear for the earlier years, but then began to increase a little bit more significantly toward the more recent years. But why do you think that may be? Perhaps discuss this in class. Part B of this question then asks you to suggest why there was a large rise in the amount of carbon dioxide in the atmosphere after around 1950. Well, the board has identified two possible answers you may have given here, one of which is because of the increased use of fossil fuels, the other being the increasing amount of cars, lorries, industry and factories populating the Earth. Can you think of any other reasons to why this might be? See what you can think of. Moving on to the next part then. This asks you to give one way in which we are trying to reduce carbon dioxide emissions. So you're looking for any reasonable answer here really. The ones given by the board are the use of hybrid/electrical vehicles, the use of low energy electrical appliances, the use of renewable energy resources, or the use of other techniques such as carbon capture and storage, or more commonly known as CCS. You perhaps could have said something along the lines of using buses to carry out mass transportation rather than using multiple vehicles, or even something like walking more often. Any sensible answer is good here. So, the final part of this question then asks you to select the right statement that supports the opinion that changes of carbon dioxide levels are not responsible for global warming. So, here's your statement selection. And the answer here is going to be the third statement. Now, the reason why is because if you look back at both the graphs from the last slide, then you can see that the CO2 levels rise between 1950 and 1980, but the global temperature doesn't really alter that much. So this statement supports the fact that changes in CO2 levels are not responsible for global warming. As for the other statements, the first statement is simply stating something. It may be indicative of some trend to do with increased electricity use over the last few years and increasing CO2 levels, but there isn't too much you can infer from this regarding the question. The second statement could be linked to how the increasing amount of industry caused increased CO2 levels and thus the higher temperatures, but this is not what we are looking for. Now, statement number 4 is similar in what it may be saying about increasing CO2 levels and increasing global temperatures, like statement 2, and this is in regards to the increasing number of household cars this time. As for the final statement, it's perhaps indicative of making a link between using less energetic appliances, which may then lead to a decrease in CO2 levels and thus global temperatures. But this has nothing to do with what the question is actually after. Moving on to question 2 then, it asks you to describe an experiment that you could carry out to show that carbon dioxide gets produced during a carbonate decomposition reaction. So, the test for carbon dioxide gas is generally the use of lime water, which will turn milky upon having carbon dioxide bubbled into it. Thus, your method would be as follows. You will firstly take your carbonate in a test tube or boiling tube that is connected to a delivery tube and then heat it up until it starts to decompose. Now, as long as you have your delivery tube then attached at the other end to a tube of lime water, you can bubble in your carbon dioxide and watch it turn milky as the carbon dioxide enters the lime water. So this was a nice quick little question. Moving on to your third question then, you are given the following data and the depiction of a typical method for separating the fractions of air using a fractionating column. And your first question is to state the main reason to why hydrogen is not separated during the fractional distillation of air. Now, you're given a few options for this, and what you'll see is that if you look at the data in the top right-hand table here, you'll see that hydrogen has a boiling point of minus 257.9 degrees Celsius, and in the fractionating column, you're cooling your air down to minus 200 degrees Celsius, which is actually above the boiling point of hydrogen gas. And so that means that your hydrogen would still be a gas at this temperature. It never turns into a liquid. And therefore, the correct answer in this question is statement number 3, which states that hydrogen does not become a liquid on cooling to minus 200 degrees C. Now, part B of this question then asks you to tick the reason to why carbon dioxide becomes a solid during the first part of the distillation process. So again, looking at the boiling points in the top right-hand table here, you'll find that carbon dioxide has a boiling point of minus 78.5 degrees Celsius. And if you look at the third comment box in the distillation method, so here it is, it says that after cooling to minus 200 degrees Celsius, the solid carbon dioxide is removed. Now this suggests that the melting point of carbon dioxide is above minus 200 degrees Celsius, as it has not yet melted and liquefied. Therefore, your answer is going to be statement number 2, which says that carbon dioxide has a melting point above minus 200 degrees Celsius. Going on to part C then, it asks you to describe how nitrogen, oxygen and argon are separated by fractional distillation in terms of their boiling points. Firstly, you must state that it's because the gases have different boiling points to begin with, then this is the major reason to why they can be separated by fractional distillation. Your next point to make is based on the data given in the question. Now, it shows that nitrogen has the lowest boiling point, which means that it will evaporate off first from the liquid as it starts to heat up. And it's because you're starting the gas off at the bottom of the fractionating column. Your nitrogen will still be a gas until it reaches the cooler top end of the column, where it will then be cool enough for it to condense off and be separated from the liquid air mixture. Now, something analogous can then be said for the oxygen, as it is the substance with the highest boiling point and will thus condense toward the bottom of the column. And this is exactly the point that you should then make. So, nitrogen having the lowest boiling point will evaporate off first, whereas oxygen, as it has the highest boiling point, will evaporate off last. The final point you should then be making is that as a consequence of their different boiling points, the gaseous components of the air can be collected at different regions of the fractionating column, as they will all liquefy at different temperatures, as I have just exemplified using nitrogen and oxygen. Part D then will ask you to use the data from the question once again to calculate the number of tons of air needed to produce 700,000 tons of argon, but in standard form. So to calculate this, you can see that argon makes up 0.93% of the air, and in terms of fractions, that will be 0.93 over 100. So therefore, to get the amount of air that we need, we'll basically take the 700,000 tons by 0.0093, so that's your 0.93% divided by 100, divide them both, and then essentially this will allow us to get the amount of air that we need to contain the 700,000 tons of argon. And as you can see, this value turns out to be 75,268,817.2 tons of air, so quite a lot. And if you go ahead and round this up, you get out 75,300,000 tons of air. And so, in standard form, you therefore require approximately 7.53 times 10 to the 7 tons of air to obtain 700,000 tons of argon. Okay, so now on to the fourth question. First off, you're asked to state how the balance of carbon dioxide and oxygen are maintained in the atmosphere, and you're also asked to explain why carbon dioxide levels are rising and how this can lead to global warming. So, to maintain the levels of oxygen and carbon dioxide, we can use the processes of respiration and combustion, as these processes use up oxygen but produce carbon dioxide. We can then use photosynthesis to use carbon dioxide and produce oxygen. In terms of how rising carbon dioxide levels lead to global warming though, you must discuss that burning fossil fuels release carbon dioxide, and due to how there is deforestation going on too, there will be fewer trees to photosynthesize and take this carbon dioxide away. And then, as a consequence of the above point made, then it's because carbon dioxide traps heat energy, there will be less heat energy able to escape the Earth, thus causing global temperatures to rise and therefore global warming. Part B of this question then will ask you to describe how carbon capture and storage works. So for those in higher tier, this question will be applicable for you, and so your first point to make here is that carbon dioxide gets trapped. From here then, the carbon dioxide can then either be stored underground, as an example being in old oil fields. It may either be turned into a liquid or a solid, or it can even be reacted with another chemical. Either one of these three reasons will gain you your second mark, but you could have given any other reasonable answer here though. Now, the next part of this question is to do with your empirical and molecular formula determination. Let's then take this oxide of nitrogen that contains 30.4 grams of nitrogen and 69.6 grams of oxygen. To determine the empirical formula, you will firstly take the number of moles of each species in the oxide. So, for your nitrogen, this will be the mass of the nitrogen divided by its relative atomic mass, and so, in this case, it will be the 30.4 grams of nitrogen you have divided by its relative atomic mass of 14 to give you 2.17 moles of nitrogen in this oxide. For your oxygen, it's then the 69.6 grams divided by its relative atomic mass of 16 to give you 4.35 moles of oxygen in this oxide. The ratio of nitrogen to oxygen in terms of the number of moles of each species can then be calculated to be 2.17 to 4.35. The simplest ratio of these numbers of moles is then going to be 1 to 2, which is essentially derived by dividing your ratio components by 2 in this case. And therefore, your empirical formula is NO2, because you have, of course, double the amount of oxygen in comparison to nitrogen in that simplest ratio. What about determination of this oxide's molecular formula then? Well, the next part of this question tells you that this oxide's relative molecular mass is 92. And so, to retrieve your molecular formula, you can simply take the relative molecular mass of your empirical formula of your oxide, which is going to be 46 in this case, and you will then essentially divide your molecular mass of your oxide by the molecular mass of your empirical formula of your oxide, which is going to be 92 over 46 in this case, and this will tell you that there are 2 empirical formula units within your oxide's molecular formula. And so the molecular formula of your oxide is simply going to be double that of the original empirical formula that you had, and this is therefore going to give you N2O4 as your molecular formula of your oxide. And so, making our way to the halfway point now, we have question 5, which asks you to determine what gases have what particular functions from a given list. So, part A, your gas used to fill a weather balloon is helium, and this is just going to be a fact. So, part B, the gas that will relight a glowing splint is going to be oxygen. Remember this from your gas tests. Part C, the gas that will turn lime water milky is going to be carbon dioxide. And remember this from a couple of questions back too. Part D, now there are 2 gases that primarily made up the Earth's atmosphere. These are going to be carbon dioxide, and it's also going to be water vapor too. And lastly, part E asks for the gas produced in photosynthesis, oxygen. You'll remember we discussed this in the last question. Now, your next load of questions were about the tectonic plate theme of things, and so moving on to question 6, this is your QWC question, and you must explain what happens at both constructive and destructive plate boundaries. So we'll start with destructive plate boundaries first. Here, this is where you'll find oceanic and continental plates moving toward one another, and when they collide, the oceanic plate, that is more dense, will be forced beneath the continental plate, which is less dense. The friction we get when this actually happens causes earthquakes, and the plate that gets subducted in this case actually melts and the rising magma created from the melting plate can cause the formation of volcanoes as the magma erupts from the surface. This phenomenon can also cause mountains to form too. To then give an even better answer, you can give a named example of one of these plate boundaries or label it on the diagram. So, I've picked out two on the diagram up here. So we have the destructive plate boundary between the Nazca and South American plates, and we then have the Eurasian and Pacific destructive plate boundary too. Now for the constructive plate boundaries. So here, the plates move apart, and when they do so, magma will come along and fill up the gap created by this movement. From there, new so-called igneous rock forms and seafloor spreading occurs. Now again, you can give a named example or draw a cross in the diagram for an even better score. And with these constructive plate boundaries, you can see that I have denoted two of these in green. So we have the constructive plate boundary between the African and the South American plates, and then at the very top here we have the Eurasian and North American plate constructive plate boundary. Another point to make here is that it's actually pointless making any reference to conservative plate boundaries, as this was not asked for in the question. And as a rough guide for you, the board has then set up the following criteria if you want to see how your answers compare to this. Moving on past the QWC to question 7 now, and the first part of this question, analogous to the last question, asks you what happens at a destructive plate boundary. The explanation is the exact same as for the last question, so nothing new here. The next part of this question then asks you to identify on the diagram on the bottom right here a constructive plate boundary. So I've already mentioned those between the South American and African and North American and Eurasian plates. The other possible answers in this case are those between the Pacific and Nazca and the North American and African plates. You can see these plate boundaries on the diagram by the direction of the arrows, which show you which direction the plates are moving in. So here's your Pacific and Nazca plate constructive boundary, and then here is going to be your North American and African plate boundary. Alike in the QWC, you're then told to describe what happens at this boundary type, and analogous to the explanation in question 6, here's your answer. This time around though, you don't need a massive description here, as the question is only worth 2 marks. Now, the final part of this question asks you to state what can happen when two plates slide past each other. And the answer to this is that we can get earthquakes as a result of friction between the plates as they slide past one another. Getting close to the end now, here's question 8. So by looking at the plate boundary images on the right here, the problem was to match the image to the correct boundary type. So A in this case would be a constructive boundary, so you can see the plates moving apart. B would be a destructive boundary, the plates are coming together. And C would then be a conservative plate boundary, so they're sliding past one another. So next part then will ask, what will happen as a result of the movement shown at boundary type A? Well, as we now know this is a constructive boundary, then we know from previous questions that when the plates move apart, magma will rise. This will then fill the gap created by the plate movement and can then go on to create new igneous rock that can actually potentially go on to form new islands. Now, lastly for this question, what will then happen at boundary C as a result of the movement shown? Well, given we know that boundary type C is a conservative boundary, then from the last question we know that earthquakes will arise from this movement. These earthquakes are then basically due to how the plates are rubbing against each other and are therefore causing a build-up of friction when they do so. Now, for your penultimate question, the first part asks you to write a word equation for the process by which carbon burns to form carbon dioxide. This would be an example of a combustion reaction, and so your word equation would be taking carbon with your oxygen to form carbon dioxide. Next up, name one environmental problem caused by the increasing levels of carbon dioxide in the atmosphere. Well, there's an array of answers you could have used for this. Check them out. You've got habitat destruction, climate change, increased flooding, loads of options. And so with that, it brings us on to the last question in this sheet. And so starting off, state the evidence that Alfred Wegener used to build his theory of continental drift and explain why scientists refuse to accept such a theory. Well, you have a choice of 3 pieces of evidence here. The board only wanted 2 though. So you could have mentioned that there were similar fossil patterns found on different continents, indicative of the continents once being joined together. Or you may have said that there were similar rock patterns found on different continents also. Exact same indicator as the last piece of evidence. Your third option was then saying that coastlines of different continents seem to look like they fitted together like a jigsaw puzzle. Now, the reason why scientists didn't want to accept this theory though was due to how Wegener had no suggested mechanism or explanation to how the continents were able to move in the first place. The next part of this question then asks you to look at this diagram in the bottom right hand corner here and describe what was happening at this particular plate boundary. You can see that this is a constructive plate boundary, as we've seen in other questions, and so you can say that at this boundary the plates are moving apart and magma will come along to fill up the gap created by this movement. The magma will then cool down to form igneous rock, which can then go on to form islands and so on. Lastly then, you must label this diagram and show the oldest piece of rock. As you're looking at a constructive plate boundary then, the oldest rock will be situated at both the far left hand or right hand side of the boundary, as denoted by my crosses here. And this rock was created by the plates splitting apart longer ago than the rock closer to the boundary, as you would expect. And so with that, this would then wrap up this particular video presentation on this exam style sheet. And so thank you for watching and listening.